to this one.
Okay, the floor is yours.
Cool. I'll start. So, hi everyone, I'm Nicolas, and I was chatting with the Nicolas a couple months ago about functional programming stuff, and he invited me here, so I'm giving a talk today. And I'm giving a talk about a game that I made, actually, last winter. My idea today is to tell you a little bit about it. It's a simple game. Get you to play it a little bit if you want, and if you have your laptops. And then to talk you a bit through how I made it. And I made it using Haskell and PureScript, so this is why I thought it would be relevant here. Is this? So first, I thought I would introduce myself a little bit. So I'm a PhD student here, but in the data science and AI division. My research mostly focuses on using large language models to help social scientists. So kind of developing unbiased ways to use these models and looking at that. And I previously did a master's here at Chalmers in complex adaptive systems, none of which has much to do with functional programming. But in a previous life, I used to be a software engineer at a company in Finland called Relics. And this company had a small team of Haskell programmers that were responsible for an internal deployment tool. So that's what I did. I spent 3 years there as a software dev, and beforehand, I studied computer science in the UK and did a little bit of PL research for my master's there. So this is sort of my background.
So is PL programming languages or something?
Yeah, programming languages. I'm sorry. Yeah, and so I haven't done much of this at all in the last 3-4 years. So I got an itch to scratch last autumn when I got this idea for a game and decided to spend some time making it. So this is what it looks like. So the idea of the game, it's called Can You Tell? And it's a game where users can take turns to send messages to each other, a bit like a basic chat app, right? But then half the time, instead of sending a normal message, you have to prompt a language model to send a message for you. And it's random, and you cannot control this. So the language model will then write the message for you and send it directly to the other user. But the user won't know whether it was you who wrote the message or whether it was the language model. So it's a sort of a Turing test-like situation. And there's these 2 buttons underneath, which means that you can guess. So at any time, you can make a guess. If you guess that the message comes from the user and actually is correct, then your opponent loses a life or a star. And if it's the other way around, if you guess incorrectly, then you lose a star. And you win if your opponent loses.
Do I know when I'm prompting an LLM to send a message?
Yes.
Okay.
So normal, the screen will be blue, and then when you have to prompt, it'll flash red.
Okay.
Yeah. And that's it. Very simple. And I implemented it into a website. And if you want, you can try it out.
You need a laptop, or does it work?
It does not work on phones.
Okay.
No. So, yeah, head over here. You need to sign up first. I put a token also, so that not anyone can sign up, and I don't get a lot of crap from bots. Yeah, and then log in and find a partner and try it out.
So can 2 people in this room play against each other?
Yes. The only rule really is that you can't see each other's screens, because otherwise you know if it's a prompt or not. And I guess for those that don't have laptops, maybe I can play against someone, if someone's willing to play with me.
You own, there's no one else in the...
What do I put in the token?
It's down here.
Okay.
Or maybe they just appeared.
I was hoping that there were.
Okay.
Is anyone else logged in apart from Robert?
Wait, do I need to find a user by name or?
Yes.
I think you can.
So did you just type binary now?
It popped up, and I
Ah,
clicked
okay.
inner, and now it said inner said hello.
So, who would like to play with me?
Oh no.
Yeah.
Sure. Did you put the I as a?
But now it's her turn, I guess.
How do they?
Okay.
Do I wait?
Which one did you?
Okay, it's the full one.
I mean,
I forgot I had it.
I heard her typing, right, and it sounded like it was about 9 characters.
Cheating.
Okay.
Yeah.
Alright.
Oh, so I was wrong.
This,
What did you guess?
I put this.
Oh, you put that. So did you
I
did you
just- I
guess
guess I
what
just-
hers was?
No.
So you don't have to guess for the thing to continue.
So it looks like a 90s Macintosh.
Yes, I was trying to go
Very nice.
for something like that.
Yeah.
Because you did this.
This is like a
How
easy.
do you?
Is this
True, you should be looking away. Okay, but I guess we can try and guess it.
Sorry.
I wanna-
Right,
Wrote
so
that.
now.
I need to do
and
this.
then that's yes.
I don't know what to
And then
write.
she guessed that.
This is the guess,
Uh-huh.
I think. This is my understanding.
So you don't have to guess even though the buttons appear there.
You don't. Yeah.
Wait,
Because
you don't get to guess from the beginning or.
the first messages are always not
Okay.
prompts.
No, I can't. I have to wait, I guess.
Right, because it's her turn. Oh,
Let's see. Okay, yeah. So this is what happens when
You see if I
oh, you can open up another one at the same time.
I was trying it.
The names are there, look.
The names are the. Oh, wait. Okay.
Oh, but those are like his. Those are your other chats, but we don't have access to those people, do we?
so these are my chats
Right.
for my user.
Okay.
Yeah. So there should be like a if you press the new chat button, then you can start your own.
It is a bit cheating for you.
Yeah.
Yeah. All right. What do you think? Do you think it's a user or LLM? To me, it sounds a little suspicious.
Well, you know.
It sounds like an LLM. The question is, are they trying to fool you, right?
Right.
Yeah. So strategically, like
Yes.
the idea is you want to get
Sorry.
the LLM to sound as human-like as possible,
What's your
or the human to sound as LLM-like as
Right.
possible.
El monado.
What?
Yeah.
El monado.
En monado. Nu är det.
So what?
Robert.
Okay.
Capital R.
What LLM is it?
It's a Llama 3.3 or something. Oh. I guess it swapped immediately.
Are you playing with everyone?
I'm unable to
Because you're
type
the
you any
stream.
reply. Like I.
Yeah,
you
it
don't
does
like
Because it's frozen.
Oh. But seems like there's a bug there. Let me try and continue here.
I thought you wrote this in Haskell. Haskell has one. It's impossible to make bugs in Haskell.
Nah, that's Agda.
Check.
Ah, yes.
So I have
Okay.
a gameplay question.
Yeah.
You can just win by choosing a person when you know it's definitely a person. So you can. I feel like it's easy to win if you just click person all the time. I mean, not all the time, but on easy messages, you click person
Yeah.
and then you made it another day runner.
Yes, but if the other user takes a bit more risks, because it's one message at a time.
Yeah.
So if the other user takes a bit more risk and decides to put like LLM messages also,
Can you reply?
then you can win faster.
Have you replied?
I got your message in the chat with Inari.
Wait, what?
Which makes it a bit,
Invite the Isaac weird.
No, I didn't get your reply at all.
oh yeah, because I sent it to Inari. Which is probably quite confusing for her now because she gets German reply to an English message.
Okay, I see that like if I have multiple people playing with me, which has never happened before, then it flips automatically to that chat.
Wait, so did you get the message?
You
from
should
Robert
send
and
that.
yours from me? Oh.
And also the chat doesn't seem to
Problematic.
count. Yeah, and this is broken also.
I mean, showing your thing in public is a surefire way of finding bugs.
Yes.
There are quite many people, I guess, logged in right now.
Yeah. Okay. But I think you got an idea for what it looks like. So I thought maybe let's go back, and my goal for the rest of the talk is basically to show you a little bit how I made it, a little bit of how it works under the skin, and to give you and to ask for some ideas and suggestions and help if you feel like writing a bit of Haskell. Okay. So how it's made. I guess my overarching philosophy for this project was to keep it really, really, really simple, or as simple as I can, and to have fun making it. So kind of using things that I knew and that I enjoyed coding with. And I mean, it's a website. It's a website with a client made in PureScript, a backend server made in Haskell, and a very simple database with SQLite. I went with that because I didn't need much data. And the server and database are stored on a droplet in DigitalOcean, which is like one of these cloud infrastructure companies. That is not one of the huge ones. So went for that.
Can you say what PureScript is?
Indeed. So PureScript is a Haskell dialect that compiles to JavaScript. I'm assuming kind of people here know Haskell, roughly. So maybe, okay.
Good assumption.
You can actually compile Haskell directly to JavaScript, but PureScript is sort of designed to be compiled to JavaScript from the start, and it especially has these really nice record types that map super nicely to JSON, and that makes it a bit nicer to use for this. And it has a really nice build tool called Spago. So if you haven't checked out PureScript and you like Haskell, it's a fun one to spend a couple hours with. Sure. And then within PureScript is this big library called Halogen, which is basically React, the JavaScript library, but with types. And so we have this component architecture where UI components have their own state and can talk to each other and so forth. So they have this basic building block, and components can do tons of stuff, can accept input, they produce HTML that the user can see, they keep their own state, they can update their state based on what the user does, they can communicate with other components and perform effects in response to events either from the server or from the user. So it's quite a complex basic building block. But I did not go for that. I went for a simpler framework, let's say, inspired by Elm, which is another kind of front-end functional programming language, where we have a much simpler model where you have some model state, the view, which depends directly on the model. So updating the model automatically updates the view, and the view is what the user sees. So it's your DOM, it's your HTML, and so forth. And then actions or from a user, like a click or pressing enter, or events coming from the server, go through one big update function, which then goes and modifies the model, which modifies the view, which can then trigger the update function, and so forth. And this is really nice because it's very simple. So my components only do two things, really. They produce HTML, and they perform these async effects that go through the update function. So then I'll walk you a little bit more in detail through what these three things actually do to showcase a little bit of what PureScript can do. So first, the model. So the model is a value of a state type. So here I have the connection, the WebSocket connection to my server. I have some banner that displays above, say when a user logs in or not. And then I have this page state thing. So I have, my application is divided into different pages, and each page has its own state. which is quite nice because it means I can't leak state between pages, and adding a page is quite easy because everyone has their own state. So yeah, it's just a simple sum type. And the state for the game page, for example, will be something like this. So I keep the username of who's currently playing. I keep the list of contacts that you saw on the left-hand side, and the state of the current chat. And the state of the current chat is just another product type of stuff. I won't go through all of it, but yeah, like the state of the application is organized like this hierarchically, and changing pages is just about changing that page state value in the main state type.
This is one of these record types of PureScript.
Yeah.
So, okay, it's a type area, so you don't have to name the type. Or...
Yeah, exactly.
Sorry, construct.
Yeah. And it's yeah, exactly.
Do these names have a global scope, like in Haskell records, or are they?
Yes.
Yeah,
they
so you
work
have
like...
to have different names for all records.
Yeah, that's a little bit annoying.
Yeah.
That's kind of why I have.
That's annoying. Yeah.
Yeah. I'm pretty sure, at least. Maybe you could do some module things where you can keep the types in a particular place and then scope it that way. But yeah. So that's the model. And then the view. So the view is what makes the HTML that the user will see, and is what also defines the actions that the user can do, which are events or clicks or things like that. And the view follows the same structure as the model. So here you have the different pages, you have the chat, you have the contacts, etc. So each of these modules has a render function that takes the state for that page from the model and creates this game component thing, which is the HTML. The HTML is defined using a domain-specific language built into this halogen library. So here I have a div containing some CSS classes. There's another div that contains some text and then an input. So this is the username for on the login page. So it looks like this, and you build up these kind of big lists of HTML components. And of course, these are just functions, so you can reuse them. You can use all of the nice functional things on these. And then actions are also defined within this structure. So in this case, I have a button, and on this onClick method, if the DOM kind of perceives this click, then it will send this action send message thing. And this is one of the things that is sent then to that big update function I was talking about. So the view is defined all in one place.
Well, just curious. The onClick, it takes a function. What is the input to the function? Is it a complete?
I think it takes the description of the event.
Okay.
So that's why I have const here, because I don't care so much.
Yeah.
But if I was like drawing something or something, you might want the position on the screen or the timing of the event or things like that.
Okay, cool.
No.
So you mentioned halogen and you mentioned Elm. I don't understand the connection between these two.
So Elm is a separate programming language.
But you also mentioned PureScript. So,
right, but so Elm kind of popularized the model for doing applications.
Oh, okay, so Elm is related work. It's not part of your work.
No, it's not.
okay.
Yeah, sorry, I should have specified.
Okay.
Elm is a separate language, and it's a very opinionated functional programming language for the front end, and it has this Elm model, which is what I'm using. So I'm using their model, but in PureScript because it's more powerful than Elm. And then so the styling for everything is done into one huge CSS file. which I would not recommend. I tried to organize it a little bit with this kind of block element modifier style, where you sort of name things in a bit of an appropriate way. But I was lazy about it, and it kind of bit me because I spent a lot of time doing CSS. Although I will say language models are pretty good at CSS these days, so that's a bonus at least. Yeah. So then the update function. The update function is what updates the model and also talks to the server. And it takes in these actions or messages, which are also just defined as one big sum type. And some actions take also extra parameters based on if you need information to do whatever action you need to do. So here, like the action to make a guess, well, I need the username of the person that made a guess, the ID of the message, and what guess did I make, for example. So then these actions are handled by one big, beautiful function. That takes an action and performs this game-n computation, which is essentially just an asynchronous computation that also has access to the model state underneath. And each of these actions can, well, update the model, as we say. So for example, here I turn the banner off, and I go to the page game, and just the default one. So this is just when you sign in, when you log in. So you get your username, you have no context, and your chat state is none. So you have to find someone to chat to, etc. And then you can also send actions. You can also send actions to the server. So here I'm asking, hey, what are my contacts? So I know who to find. Events from the server handle the same way. So when I perceive something from the server, I get this server action instead. This can be one of many things, and then the handlers for each of these do the same. So they can update the model, they can send further actions to the server, and that's pretty much it.
So what happens if the update function is slow?
Sorry?
What happens if the update function is slow?
Good question.
Does it freeze?
I don't know. It's not something I've had to think about. Also because, I mean, this website is pretty simple. But yeah, I don't know. It's a good question.
And what do you do prompt? You're asking them to do something. Maybe the server goes down for a while.
Yes. But then I have, in my model state, I have like these kind of waiting for or pending states. So I switch to that, and then I just asynchronously wait for the successful completion.
So what does the API between the front end and the back end look like? This must be serialized to JSON or something.
Yeah,
Is that
exactly.
all under the hood, or do you have to sort of define that as well?
I define it by hand. I like the control of defining it by hand. I know in Haskell you can, actually in both you can like automatically serialize, but then I don't like that because I don't want my internal implementation type names and all of that to be reflected on the JSON that I send back and forth.
So you have no type guarantees between front end and back end?
No. But this was sort of a... No, I don't. You could generate the PureScript type automatically from Haskell, for example. Like when I was working at Relix, that's what we did. We had like, instead of PureScript, we had an Elm front end, and we automatically generated the Elm types from the Haskell types. But yeah, for this one, I chose not to. Also because I like to see what the interface between the two is. But yeah, there's pros and cons. Sure. Yeah, so that's pretty much it for the front end. So now I wanted to say a few words about the back end. So it's made in Haskell because I like it, but also because it has like good supports for parallel requests. And I like to think in the functional style of Haskell. and I've been using Python now for quite a while, and I wanted to kind of go back into the nice world of purely functional languages. Yeah. So, well, essentially what it is a web server. I need to receive data from clients, multiple clients all at once, but I also need to push data back to clients. So if client 1 writes a message, then client 2 needs to automatically to get that message on their screen. Same goes for guesses and so forth. So my first try was to implement this with like a REST API. There's a lovely library in Haskell called Servant that allows you to define your API as a type, and then instantiate that type to make your server. So that was my first port of call. And then to push events from the server to the clients, there's something called server-side events. So I thought that would be a good fit. And server-side events are quite simple. I don't need to maintain like a WebSocket connection between the two. However, with this setup, it's really hard to know when a user disconnects. And so because I will need to create at least one thread per user, if I don't know when they disconnect, then those threads will pile up and my app will crash. So instead, I went for WebSockets and JSON, as you intuited. So now I have like this is the API types I was talking about. So it's just a shell that is either serves the first stage, or you have a WebSocket connection. And then everything happens through the WebSocket connection. And I can use JSON because I'm just dealing with text here. The messages are small, unless you choose to write an essay to someone else, I don't know. But it's nice and simple.
What happens if I write JSON in my message?
I think it will encode it as a JSON string, like it will.
Right, okay.
Yeah. Okay, and then I have to deal with some async operations in the backend. So as I said, I could have many users in parallel, and users can send messages asynchronously. So all of that is nicely handled by software transactional memory in Haskell. So I use tvars and queues and channels from the kind of transactional side of the STM to do all of that atomically. And that, once I figured out what the various connections should be, worked really nicely, I have to say. So first I wanted to show you, this is what happens when the server starts keeping track of a single user. So you have your client, and then the user logs in, and the first thing the server does is starts a new thread to handle that request from the user. Then that thread itself will create a TQ or a queue for the user of actions to send back to the user. And at the same time, it will start a second thread, this producer thing, that watches the queue. And as soon as there's something on the queue, it sends this server action back to the client. So as soon as the user connects, I set up a queue. As soon as I put something in the queue, it gets sent back to the client. And then this consumer thread, after it does this initial setup, just watches, like stays connected on the WebSocket connection and watches for more client action. So as soon as the client sends something, it does its thing. If something is added to the user queue, it gets added to the user queue, and then it gets sent by the producer. So all of this is asynchronous. And then it gets a little bit more complicated in the case of chats, because chats get shared between users. So here we have a similar setup as before. So the consumer has already set up our user queue. But now when I do a follow chat command, so this would be when I click on someone's chat or I start a new chat, for example, then the consumer also either creates or joins a chat channel. And the chat channel is a broadcast channel. So anything that listens to this, if I put one message in here, it will broadcast it to anyone that listens to it. And then that chat channel connects to the user queue, which then sends everything around. And it also connects to user queues for the other people. And this producer, when it listens to an action, because if I send a particular message, for example, with a prompt, then the other person shouldn't see the prompt. So it does some filtering based on who the user is in order to change what it sees. So this queue stuff and channel stuff, this was very nicely done with this transactional memory, I have to say. That's it for that bit. And then, yeah, database, very simple. SQLite database, just on the same little computer as the server is running on. There's a nice SQLite simple library in Haskell where you can parameterize some SQL commands and set up the database automatically at the start with some tables and such. I made some tests for these SQL calls. Otherwise, I haven't written so many tests. Yeah, for the language models, I used this like Llama 70B. And because like 70 billion parameters are pretty heavy, I cannot run these on my laptop or on the server node. Then I make an API call to Grok, which is one of these companies where you can just run your language models. Very simple APIs that you can just call. And in particular, with this one, if you don't have that many calls, they let you do it for free. So I don't have to pay for that at all. If you prefer to run them locally, then I would consider this Llama tool. It's quite convenient also. One of the things I haven't done is to try or let the user choose different language models. But that should be straightforward and just haven't had the time. Deployment. So yeah, I already mentioned this, but I put all of this on a DigitalOcean droplet. So this is one of these cloud compute infrastructure companies. And deployment is an SCP call. So I have a little deployment script and I put things there. There's way better ways to do this, but this is simple and it worked for me. So for now, it's good enough.
So you build this locally and you upload it.
Yeah, that actually bit me in the butt this week. Because I used to develop this on an x86 machine. But then when I was adding the token feature, then I used this Mac, and the software didn't run on the x86 server. So now I compile it on the actual server, but I only had 1 gig of memory.
Yeah, that's my next question. Are you using JHC?
Yeah.
Yeah. So your build is quite intensive.
Yes. So I had to make the droplet bigger. 1 gig was not enough memory to compile ASON, I think.
But can't you specify which platform to compile on GHC so that you can build on your machine but for the other architecture?
Maybe.
Yeah.
Virtual machine.
I didn't look into it too much, to be honest.
Okay.
You can put a virtual machine on your Mac too.
That's true. Yeah, I could. Or a Docker container or something. No. So then, yeah, I had a few reflections from this little project that, well, first of all, it was really fun. I really appreciated kind of going back into this functional programming world for a little bit. The Elm-like model also worked well. I didn't have to worry too much about connections between different components and the like. And I really liked working with this one big model type and to structure the view according to the type of the state, the structure of the state. Haskell and STM were great for async operations. Once I figured out what the queues should be, then actually implementing them was almost trivial. But then, yeah, I should have thought a little bit more about how to push things to the users and not, because I had to basically redesign the whole thing once I realized that the server-side events didn't cut it. And also should I have invested more in CSS infrastructure for sure, like using variables and all of that. And that's pretty much it. That's pretty much all I had for you today. Here are some more ideas that I've had that I maybe will implement, or if someone wants to help out with that, you'd be very welcome to. So, first of all, a mobile version would be cool. It could be cool to let users choose and even fine-tune their own models. So right now it's the same model for both players, but it doesn't have to be that way. It would be cool if you could upload your own model and then play with your own model, for example. You could use the image generation capabilities of LLMs these days. So you can send images and try and detect if the image is fake or not. Or you could have like a survival mode where instead of playing against someone else, you play against an LLM, and you have to trick the LLM into guessing whether what you wrote was from you or from an LLM. And you would just keep going until you lose, and then the amount of messages you can write is your score.
Isn't the best strategy always to probe some LLM and then paste it?
True.
So,
yeah, I guess.
so yeah.
That would be considered cheating. Then I would need. I don't know how I would like have an anti-cheat mechanism where you try and.
I mean, I guess
figure
if you pass the bit text in your chat window, it's definitely not written by you. But it's kind of hard to take
With a
control
big
of.
chunk of text appears very fast.
Yeah.
Because you just control the
Yeah.
2 key presses, but 1,000 characters.
Yeah, I mean that's another, I guess, aspect of the game. Yeah.
One of the hardest things when you have asynchronous things like this is debugging. Any thoughts about the debugging process here? When you have multiple users hanging, or we discovered today that multiple people play with you, obviously haven't seen that part before.
Yeah, I think
Testing.
I have not tested this much formally. Like, I mean, actually implemented tests. Of course, I tested it by hand. I think the atomicity is super nice because it means that I don't have to worry about a lot of bugs. But yeah, as soon as, like, if I were to scale this up, for example, and then let's say these queues wouldn't run all on a single CPU, but instead you would have like separate queues as services that can run on multiple machines, say, then I think there I would definitely invest more in testing, but this is not something I'm very good at or know how to do particularly well. No.
Are you collecting logs about the usage that you can produce statistics later? But
No,
how often people guess correctly or whatever?
I mean, I do keep the chats, yes. So I have a history of all the chats. So I could produce some statistics there for sure. But this game has not had many users. So
No, but you need to think about it early on, right? Because
yeah. I don't keep things like timestamps or things like that. But that could be an easy win.
Have you tried playing in another language?
Yes, I have.
So how good is the model for?
It's pretty good.
Okay. Because sometimes, yeah.
So I'm half French, and I played with a French friend of mine.
Yes.
And so we would swap between English and French.
Yes.
And try to fool.
Okay, so that doesn't really help the guessing.
No. I mean, I guess if you end up writing something in a language that you clearly don't know, then that would be bad. But I've also played a bit with the idea of using a language model that is not very good. Because then I would have to learn how to write like that not very good language model. So in a sense, the game is agnostic to how good or human-like the language model is. Yeah.
How long are the usual typical games?
Not super long.
You have 5 stars.
Yeah. I mean, it depends how much users like to guess. But I think 10 and 15 messages, something like that. Yeah.
I was going to ask, what your inspiration was. I mean, basically the imitation game, or was there some other kind of motivation for you to build this game?
The original idea was like I wanted to write a bot for like WhatsApp or something like that, answer messages. And then that got me thinking of like, okay, would the other person notice? And so that's why I ended up making this game. Yeah, but it's usually pretty easy to spot large language model text. Like there's even a paper that came out this year that shows that if you're a frequent ChatGPT user, they took 5 kind of frequent ChatGPT users and got them to try and classify longer non-fiction documents created by LLMs or not. And I think they had them classify like 300 documents each. And if you go by like majority vote of those 5 users, they got like 299 correct. So in that sense, it's quite easy. But here it's a little more devious because the human text is trying to be like the language model texts, ideally.
But you could imagine if you have a certain number of users and you can produce these kind of statistics, I mean, writing such a paper. It's about
that would be cool.
The easiness or difficulty of detecting.
Yeah, it's let's say this was a kind of for fun project for me, so I hadn't thought about it too much from a research perspective, but absolutely. Yeah. Yeah.
I think there's a board game which is similar to like Turing Test, but I forgot its name. I will tell you maybe at the end of the day. But the idea is that you play 2 people, and one of them gets a card, and then it says you're either a robot or human, and the instructions are different. And the person who is playing as a human and needs to guess as an investigator, they get some kind of ideas what to ask for. And I think that might be a good idea to add some kind of like idea what you will chat about. Because I think at the beginning it's a bit kind of like you say hello, and after that you're like, okay, what do I actually ask so I can actually prompt another person to like write a long answer, or if they have a prompt like so maybe some kind of hint for users what the chat would be about.
That's a great idea.
And I think that's what like in the game they also like you can choose a block of questions. I mean there's kind of investigator, you investigate another person.
Yeah.
But you still have like thematic blocks of questions, and maybe something would help a lot.
Yeah, I had a couple ideas around that in the past. One is that so the language model is given a short like system prompt, but then you could add the theme to that system prompt and show it to the users. So you could tell the language model to absolutely only talk about whales. And then as a player, you would have to like adapt to that knowledge. Another idea was to make it a bit more like dating app-like. So you would generate a profile for each player, like a photo, a name, and so forth. And then you have to play as that person.
That sounds extremely creepy.
But it would be like, I in my head at least, it's not like hyper realistic, right? It's just
catfishing training camp.
Yes.
Catfish with your colleagues. You could do something like improv theater sort of prompt, like act out a scene where you're planning a dinner party or
yeah, that could be fun.
Yeah, but I think assigning user roles in some situation would be fun because you would all like it. I guess if you want people to act like LLMs, it would also kind of give them some kind of idea how LLM would also respond in this given this prompt.
100%.
So what's the system prompt? Does it say something like add occasional typos or something like this?
I think it just says to pretend to be a human.
Let's go for that.
We can. I think I had it on the like a. Yeah, there you go. It's the current system prompt.
Right, so the LLM is pretending to be human and I'm
Right, so it's
pretending to reply like the LLM. Nice. That was a very fun game. Fun experiment.
Thanks. Yeah.
Okay.